Hello guys, welcome to my channel. In this tutorial, we are going to talk about C programming, the basic of compilation. Please, if you have not yet subscribed to my channel, please go back, subscribe and then come back. Now, having covered the basic concept of C programming, we can now briefly discuss the process of compilation. So you, as a programmer, as you take this course, it's very important to understand the compilation phases, the process of compilation. So please, let's go ahead and explain what is that all about. Like any programming language, C by itself is completely incomprehensible to a microprocessor. Its purpose is to provide an intuitive way for humans to provide instructions that can be easily converted into machine code that is comprehensible to a microprocessor. The compiler is what translates our human readable source code into machine code. To those new to programming, this seems fairly simple. A naive compiler might read in very source code file, translate everything into machine code, and write out an executable that could work but has two serious problems. First, for a large project, the computer may not have enough memory to read all the source code at once. Second, if you make a change to a single source file, you will have to recompile the entire application. To deal with these problems, compilers break the job into steps. For each source file, each .c file, the compiler reads the file it references via the h-include directive and translates them into machine code. The result of this is an object file .o. After all the object files are created, a linker program collects all the object files and writes the actual executable program. That way, if you change one source file, only that file needs to be recompiled, after which the application will need to be relinked. Without going into details, it can be beneficial to have a superficial understanding of the compilation process. The first step is the preprocessor. The preprocessor provides the ability for the inclusion and so-called header files, macro expansions, conditional compilation and line control. These features can be accessed by inserting the appropriate preprocessor directive into your code. Before compiling the source code, a special program called the preprocessor scans the source code for tokens or special strings and replace them with other strings or code according to the specific rules. The C preprocessor is not technically part of C language and is instead a tool offered by your compiler's software. All preprocessor directives begin with the hash character. You can see one preprocessor directive into the Hello World program that we saw in the previous tutorial. The H or the hash include stdio.h. This directive causes the stdio header to be included into your program. Other directives such as h-pragma controls compiler settings and macros. The result of the preprocessing stage is a text string. You can think of the preprocessor as a non-interactive text editor that modifies your code to prepare it for compilation. The language of preprocessor directive is agnostic to the grammar of C, so the C preprocessor can also be used independently to process other kinds of text files. So please, I hope you got the point for the preprocessor phase, which is the first step. Second, we have what we call the syntax checking. This step ensures that the code is valid and will sequence into an executable program. Under most compilers, you might get the message or warnings indicating potential issues with your program, such as conditional statement always being true or false, etc. When an error is detected in the program, the compiler will normally report the file name and line that is preventing compilation. So that's the point about syntax checking. Another step is the object code. The compiler produces a machine code equivalent of the source code that can be linked into the final program. At this point, the code itself can be executed, as it requires linking to do so. It is important to note that after discussing the basics, that compilation is a one-way street. That is, compiling a C source file into machine code is easy, but decompiling, that is, turning the machine code into the C source that creates it, is not. The compilers for C do exist, but the code that create is hardest to understand and only useful for reverse engineering. Another step or another phase is the linking. Linking combines the separate object file into one complete program by integrating libraries and the code and producing either an executable program or library. Linking is performed by a linker program, which is often part of the compiler suite. Common errors during this stage are either missing or duplicate functions. Another step or another phase of C compilation program is what we call automation. For large C projects, many programmers choose to automate compilation, both in order to reduce user interaction requirements and speed up the process by recompiling only modified files. Most integrated development environments, that is IDEs, have some kind of project management which makes such automation very easy. However, the project management files are often used only by users of the same integrated development environment, so anyone desiring to modify the project will need to use the same IDE. I hope guys you enjoyed the point about the phases of C program compilation. Please, it's very important, it's very fundamental to understand this before we go ahead. Please, if you have not yet subscribed, please go back after this, you then subscribe so that you can get in touch if there is a new video or new tutorial. Hope you enjoy guys, and then see you next. Bye.